Okay, so let's take a look at balancing some chemical reactions. So we'll start with a pretty easy one. This first chemical reaction, we have magnesium plus oxygen yields magnesium oxide. One of the first things I like to do is draw a T-chart underneath the reaction. And then I divide the T-chart right underneath the arrow. And the next thing I like to do is take an inventory of the types and numbers of atoms I have. So on the reactant side, I have magnesium and oxygen. On the product side, I should have the exact same types of atoms. You'll see I have a magnesium and an oxygen atom. Okay, now I'm going to take a count of the number of each type of atom I have on the reactant side and the product side. Just to make this a little bit easier, the reactant side is always left of the arrow, and your products are always on the right side of the arrow. So you can see here I have two reactants and one product. Since there's no coefficients or any subscripts written after the magnesium, we know that we have one magnesium atom on the reactant side. This 2 subscript indicates that I have 2 oxygens on the reactant side. On the product side here, we can see that I don't have any coefficients or any subscripts, so I have 1 magnesium and 1 oxygen. If there was a 2 subscript here, like there is over here, then I would have 2 oxygens, but nothing's there, so I assume it to be 1 oxygen. Here we can see that the number of atoms on the reactant side for magnesium and the product side for magnesium is the same. 1 atom here, 1 atom here. So that's balanced already. If I go down here for the oxygen atoms, I can see that I have 2 oxygen atoms on the left, or the reactant side, and 1 oxygen atom on the right, the product side. This means that this reaction is not balanced. What I'm allowed to do is write coefficients in front of each reactant or product. So I'm going to draw some blanks here. Normally we don't draw these blanks, but this will indicate where I'm allowed to put whole numbers or coefficients to balance this out. So since magnesium is already balanced, I'm not going to add anything there to this blank right here for right now. What I'm going to do is add a 2 right in front of MgO. By adding this 2, I multiply everything behind it by 2. So this changes my magnesium from 1 to 2, and it also changes my oxygen from 1 to 2. So now I've managed to balance my oxygen, but by doing so I've created another problem. Now I have 2 magnesiums on the product side and only 1 magnesium on the reactant side. So to compensate for this, I'm going to go back to the reactant side and add a 2 in front of the magnesium. So now I have 2 magnesium atoms on both the reactant and product side, and 2 oxygen atoms on both the reactant and product side. So this equation is officially balanced by adding a 2 here and a 2 here. So, like I mentioned before, this is an easy one. Let's look at one that's a little bit different, a little bit harder. Okay, so this one's a little bit more complex, but we're going to tackle this problem the same way as the other one. I'm going to start by drawing my T-chart. So again, I divide the T-chart underneath the arrow, and there's a lot more going on in this one, so let's figure out what types of atoms we have on the reactant and product side. So I see that we have lead, we have nitrogen, oxygen, potassium, and iodine. So this time I have 5 different elements to deal with. On the product side, I should have the exact same types of atoms. So every time you do this, the types of atoms you have on the reactant side are the same types of atoms you have on the product side, because atoms cannot be created or destroyed in ordinary chemical reactions. So now I'm going to take chemical inventory of these atoms, right? So I have 1 lead, and here's where it gets a little bit tricky. Now I have NO3 enclosed in parentheses with a 2 subscript. This means everything inside the parentheses will be multiplied by 2. So the 1 nitrogen is multiplied by 2, so that gives me 2 nitrogens. The 3 oxygens are multiplied by 2, so that's 6 oxygens. Over here it's a little bit more straightforward. 1 potassium, 1 iodine. We'll do the same thing for the product side. 1 potassium, 1 nitrogen, 3 oxygens, 1 lead atom, and 2 iodine atoms. So if I look back at this, I can see that lead looks like it's balanced, nitrogen is unbalanced, oxygen is unbalanced, potassium is balanced, and iodine is unbalanced. Something you may have noticed is that this cluster of NO3 has been multiplied by 2. So something that could be really useful is to do the same thing over here. So if I put a 2 in front of potassium nitrate, or KNO3, what that's going to do is change the potassium from 1 potassium to 2 potassiums. It'll also change the nitrogen from 1 to 2. And 2 times the subscript 3 on the oxygen will make this 6. So now if I look back, the only problem I have left is that I only have 1 iodine on the left and 2 iodines on the right. So to alleviate that, I could add a 2 here in front of potassium iodide. Now that changes the potassium to 2, and it changes the iodine to 2. And I think I missed this earlier, but the potassium was unbalanced when I added the 2 up here, because I ended up with 2 potassiums and only the 1 potassium over here. So by adding this 2, I fixed both the potassium atoms and the iodine atoms. So looking back at this, lead is balanced on both sides, nitrogen's balanced, oxygen's now balanced, potassium's balanced, and iodine's balanced. And of course we did this by adding our coefficients, a 2 here and a 2 here. Alright, so this was a look at a couple of chemical reactions and how to balance them.